Good morning, students. Today we are going to see about interrupts. Here, why we are specifically we are interested in interrupts is microcontroller can serve many devices that can be interfaced to it. Okay, whichever is interfaced to a microcontroller, the microcontroller can serve them. Okay, so how to do that service? By means of two methods, the microcontroller will serve the devices that is being interfaced with that, which is nothing but the interrupt method. First method is interrupt and the second method is polling. Polling already you know, because that is done in your timer related operations. You have generated a square waveform by using timer, right? Generated a square waveform by using timer. In that, what you have done, you have continuously, okay, you are continuously monitoring the timer overflow flag to see. You are going to monitor. Why we are going to monitor? To see that whether the count related operation is over or not, right? For example, if you are generating a square waveform in P1.0, okay, first what you will be doing, if I am telling that I need a square waveform, generate a square waveform of 3 kilohertz, what you will be doing? First you will be calculating with 50% time delay, means for on and off time the same count value. That count value you will be putting up in the timer register, and you will enable the timer by using the timer run flag. Automatically your timer register value that is being loaded to the timer register will be decremented by 1 for each clock cycle or the machine cycle. And then when the count value rolls down from 00 to FF, the timer overflow flag will be raised to 1, indicating that the on time operation is over. Then what you will be doing? Complement the bit P1.0, and again the next off time count will be loaded again in the timer register. Again you will be enabling the timer run flag or to start the timer related operation, and the counter or timer related operation will continue on and on. Am I right? Continue on and on. Here, what does the microcontroller do? What is it doing? It is continuously monitoring the overflow flag, namely your TF1 flag, continuously monitoring your overflow flag, your TF1 flag if you are using your timer 1. By continuously monitoring this flag, the 8051 doesn't do any work. It is held up in this timer related operation itself. Okay, so you are unnecessarily tying up the microcontroller in doing this timer related operation. So if you are using interrupt, you can do this operation parallelly, meaning two operations can be done parallelly. Timer will be enabled as such, as a separate sequence, okay, and you can do any program parallelly. Your 8051 can run any program, okay, and the back end the timer will be run, and the front end it will run the main program. Okay, back end you will have this subroutine program, which is nothing but the subroutine program is nothing but generation of square waveform. Let us assume that the subroutine program is generation of square waveform. Okay, the main program, let us transmit a character as we said serially. We are doing it in port 1. Okay, port 1, let us transmit the character V. Okay, repetitively. So port 1 is going to transmit V, character V, and port 0.1 is going to generate square waveform continuously. These two operations can be done parallelly if we use time interrupts. Okay. And what is polling method is, for example, in 8051 microcontroller, if I am connecting 5 devices if we are connecting, okay, if we are connecting 5 devices at a time, and all the 5 devices, whether it request the it will request the 8051 microcontroller for to get its service. And what does this 8051 do is, it will continuously monitor all the 5 devices whether it is requesting for the service, and accordingly this 8051 will monitor it and service it and give to those devices. But unnecessarily, and if all the five devices is interrupting at the same time, no priority is given to the interrupts. Like for example, some task may be very much important. Those tasks has to be performed immediately. That has to be given a high priority. But here no priority will be given in case of polling, and you will be monitoring in a round robin fashion. Okay, you will the 8051, I'm telling, the 8051 will service only one interrupt, and then it will ignore the rest, meaning it won't consider the next. First, it is no priority when it comes on the way in a round robin fashion. Whichever thing is first encountered, that will be serviced first. And moreover, all the four will be in a waited list, will be in the all the other four interrupts will be in the waited list. You cannot ignore or mask the interrupt. Only if you have a priority, a higher priority will be done, other four will be masked or ignored. Okay. And what you have done in case of your timer, you have held up your microcontroller in monitoring your timer overflow flag. That is all the disadvantage in polling method. But that can't be done in, that won't be there in your interrupts. That won't be there if you follow your interrupts. Okay. You have six different interrupts. Yeah. So as I said already, you to avoid tying down of your microcontroller in the checking the timer overflow flag again and again. Okay, interrupts are used. Okay. So whenever you have an interrupt, whenever you have, either it may be an internal interrupt, software internal interrupt, or you may have an external interrupt also. But as such, on the whole, whenever you have an interrupt, what is it this 8051 will do is automatically from the, for example, if it is if move a comma b is a current instruction that the 8051 is executing, what will be the next instruction in sequence, that address will be held in the program counter, which is nothing but 3627. Whenever your interrupt is enabled, when you enable your interrupt, what it will do is it will go this program counter value, it will move this program counter value to 2736 is LH and 36 in the stack pointer. This 3627 will be loaded in the stack value, that is nothing but the internal RAM, and automatically the program subroutine, okay, in the interrupt after loading this value 3627, the program counter should be loaded with the new address, which is nothing but the address of the subroutine, interrupt subroutine. Okay, so get the address from the interrupt subroutine, load it in the PC, and start executing this interrupt subroutine. And once that is done, go back to the main program by picking up the value that is loaded in the stack and start executing the main program. Okay. This is what it will be done in case of interrupt, whenever you have an interrupt. Okay. So you have 6 different types of interrupts. Okay. Please hold. Okay, these are 6 different interrupts which are nothing but we have 6 different interrupts here, which is your reset first, and external interrupts, 2 external interrupts which will be there as INT0, INT1 in the pin structure, in the 40 pin IC structure, and timer 0 interrupt, timer 1 interrupt, and serial 1 interrupt, serial port interrupt. These are all software related interrupts. Only these two are external interrupts, and upon reset we won't consider this. Upon reset, automatically your starting address of the RAM or ROM address will be 000H. RST is your source. Okay. So external interrupts is nothing but INT0, which is nothing but this I will tell you. External interrupt is nothing but it will happen in INT0 and INT1. Okay. So when TF0 and TF1, see this IF1 is interrupt enable 0 and interrupt enable 1. Interrupt enable 1. This we have these two flag bits we have read in where we have read we interrupt enable 1 and interrupt enable 0 we have read in the timer. We have read in the timer. These flags are in the timer registers. Okay, so now timer overflow flags is TF0 and TF1 we know, and serial port register is RI and TI respectively. RI and TI respectively. Because once this interrupt occurs, we are going to monitor these flags only. Okay, once if this interrupt occurs, we are going to monitor these flags only. Okay, these flags only. This we'll see in detail. Okay, and see between as I said, once this interrupt, for example, if there is a timer 0 interrupt, if there is a timer 0 interrupt, that is there in your 8051. When there is a timer 0 interrupt, automatically, okay, the program call will be transferred to the vector table address. What is the vector table address of timer 1000B? It will go here. And here only your subroutine program, the mini program, the subroutine program will be placed from 000B. And between 000B and next IE1, you have only 8 bytes. From 000B to 0012, which is nothing but 8 bytes only you have for writing down the subroutine program. Subroutine program. The subroutine program is nothing but if any external device or if any programmer requests the service of the microcontroller, that will be returned. That request, the service program will be done in your subroutine. Okay, that will be returned in this starting vector address from 000B. If that service program or the mini program is more than 8 bytes means, okay, simply place a long jump instruction in this address 00B followed by any 16-bit address, and in 8000 you write down, from 8000 you write down your interrupt service program. Okay, right. So that is what for long subroutines you need to use a long jump for writing down your mini program, subroutine program. So what you need to see here is your interrupt enable register. Okay, interrupt enable register. So it is an 8-bit register. So you need to enable interrupt, enable all. This is a global variable. This is a global variable. You need to make this one. Only then you can do programming by using timer. You can program the microcontroller by using the interrupts. How many interrupts you have? You have 6 different interrupts. Okay, so if this is not enabled, even though any device or if the programmer is requesting the service of microcontroller by using your interrupt, the interrupt won't be serviced. Okay, I repeat, if this is 0, if any other external devices connected to the microcontroller, or if the programmer itself needs the service of the microcontroller, okay, if they are intimating the microcontroller by means of interrupt, that interrupt won't be serviced because you haven't enabled your interrupt. Okay, so to only if you enable your interrupt EA flag as 1, whatever interrupt, that is hereafter whatever interrupts, the 6 different interrupts or the 5 different interrupts excluding your reset, whichever is you are receiving, the 8051 is receiving, that will be serviced by the 8051. Okay, these 2 pins are not used, and ES is nothing but enable the serial port. Okay, enable the serial port, and this is for timer. Enable your timer interrupt. Enable your timer interrupt. Okay, and this is your external interrupts. External interrupts INT0 and INT1. Okay, this is a bit accessible register. Each individual bit can be accessed separately. Okay, once your interrupt is enabled, for example, if you are enabling your timer 0 interrupt, okay, if you need to enable your timer 0 interrupt, you have to make this EX0 pin to be 1, meaning along with the global variable, this one, you need to make EX01, meaning you are enabling your timer 0 interrupt, the rest all will be 0. Okay, so once if you have 1, okay, so this is 0 0 0 0 0 0 1, which is nothing but 81. That is your interrupt enabled register value H. Once this is made 81, automatically this is timer 0. Timer zeros vector address is 000B, where you will be having that mini program. Okay, so automatically the program control will be transferred to 000B, and it will start to execute continuously here. Once this is started, okay, from 000B, what it will do? 000B, it will start execute your interrupt subroutine program. Okay, interrupt subroutine program, and then after doing this, parallelly it will retrieve the data that is being saved in the stack. Already I said no, that one, and it will parallelly your in the front end main program will be run, and in the back end the interrupt subroutine program will be run without wasting your time. Only if you are enabling your interrupt. Keep that in mind. So interrupt enable register, if I am using timer 0, okay, this is your external timer, so this is 1, this is 0, so this can be 81, this is 82H 10. Okay, so if I want to use timer 0, what will be your IE will be 1000 and 0010. IE should be 82H, that should be loaded in 82H, telling the microcontroller that it is going to use timer 0. So now program to generate a square waveform using timer 1. You can even take the same value, 3 kilohertz square waveform generation using timer 0 in mode 2. Mode 2, we know what is mode 2, 8-bit auto reload feature, and display the character VI in port P1 and P2. Okay, in port P1 and P2, at the same time you display V and I, and P0.2 you display your generate your square waveform. So the program is, first the starting address will be org 000H, and use a long jump, as I said, because from 000H till, see, these vector address till the next 8 bytes till 0030, from this 0000H 30H. Okay, this is your interrupt vector table where your interrupt subroutines are saved. If you have any interrupt subroutines, that will be saved here. Okay, so skip till 0030, don't use it for your program. Okay, so don't use it for your main program, because those are vector tables address. Space, it's not address, it is space. Okay, so L jump main, where is the main? So before this main, let me write org 0030H. Okay, starting from 30H, I'll be writing the main program. What is the main program? I'm going to use timer 0. Timer 0 means what you will be doing. What is your TMOD register? TMOD register, timer 1 is the upper 4 bits, timer 0 is the lower 4 bits, and mode 2 0010, and this is going to be all 0, and mode 2 0010. So 02H will be loaded. Yeah, 02H is loaded here in the TMOD register, and again it's an 8-bit auto reload value. So count value I am not specifying here, load the count value. Okay, load the count value here. So here load it down. Again enable the interrupt 82H. When you are enabling your interrupt, automatically the program counter control will be transferred to timer 0 means 000BH. So see here, timer 0 means ORG 0000H. Automatically the program control will be transferred here. There you have complement P1.2 return I, because you have loaded the count value already. This program will be running at the back end. Okay, but at the same time the main program, once the program control is transferred, okay, once the program control is transferred here, automatically see after once this interrupt is enabled, okay, the current value of the program counter will be stored in the internal RAM, and it will derive the address from the interrupt vector table. After getting the address, it will start executing the interrupt service routine parallelly at the back end. And once this 8051 is starting this activity, it will retrieve the PC. The PC will retrieve, after starting this activity, it will go and start and come back and retrieve the RAM address, and the main program will be running in the front end. Okay, in the back end square waveform will be done. In the main program, what you will be doing, you have to transfer port P1. In port P1 the character V has to be transferred. In port P2 the character I has to be transferred. Okay, you have to do this on and on in the front end as jump back. Okay, is it okay? Right, and this will also be done on and on. Complement this return I again. Okay, return interrupt in the sense where it will return after enabling this, you went here, and after completing this it has to come back here, where return from the interrupt is this. Again set B TR not 0, you are raising your interrupt flag. Set B here is what, after setting the timer run flag only you will go here. Okay, you will go here, and then you will come back where you left. Where you left is this. Continue this program again and again and do this parallelly. That's all. Okay, check this program. And coming to the external interrupt, you have two types of external interrupts, INT0 and INT1. This INT0 and INT1 is available in as a part of port 3.2 and port 3.3 input output port, and in pin structure is pin 12 and pin 13. Okay, these external interrupts can be accessed by means of two methods, either by edge triggered method or by low level triggered method. Okay, so in low level triggered method, for example, if I am having two external interrupts INT0 and INT1, in low level trigger means if any external device is requesting the service of 8051, it will indicate by a low signal. Whenever there is a signal from high to low, this is nothing but low level triggered. The interrupt will be sensed by this 8051. Automatically, when you have a low signal in INT0, the program control will be transferred to 003, and if you are sensing a low signal in INT1, the program control will be transferred to 0013. Okay, so whether we are going to use edge triggered or level triggered, that can be done. Okay, that can be done in the TCON register. You have this IE0 and IE1 pin. If this is 0, if IE0, interrupt enable for timer 0, I mean 0, external interrupt, I'm sorry, it's not timer related pin flag. External interrupt 0, external interrupt 1. If this is 0 and if this is 1, okay, if this is 1, meaning this IE0 interrupt 0, external interrupt 0 will be level triggered, and if this is 1, means that is edge trigger. Edge trigger is quite opposite to this. Whenever you have from a low to high signal that is enabled in INT 0, it means that this interrupt is, it will sense their 8051 will come to know that some other external device is requesting the service of this microcontroller. Sometimes you may have a fault signal also at this INT 0 and INT 1 that exists for some period of time. For that, what does this 8051 will do is, it will wait for 4 machine cycles and check whether this pin is continuously low, if it is a low level triggered, or if it is continuously high, if it is a edge triggered. If it is continuously low or high according to the triggering, either level triggering or edge triggering, if it is continuously high, the 8051 takes the request from the external device and then it will do the service. Okay, and once it starts this 8051, if it starts the subroutine program, automatically you need to change this INT 0 or INT 1 to high, indicating that it is ready for receiving the next service. Okay, so edge triggered, I said, whenever you have an low to high signal, that is that you are receiving it in INT 0 and INT 1, that is edge triggered interrupt, and upon reset 8051 is all level triggered. If you need edge triggered means you need to make this TCON register flag bits IE 0 or IE 1 to be 1. Okay, so now combining both the triggering level, I have given you a program. What is that program is? The program statement is this. The circuit diagram I will explain. So assume that we have connected port INT 0, INT 1 to a low 0 and 5 volts. Whenever this switch is pressed, you have a low signal. Whenever this switch is pressed, you will have a high signal. So this is level triggered, this is edge triggered. Okay, when this is pressed, you need to lit the 8 LEDs that is connected to the port P0. Assume that you have 8 LEDs connected to port P0. When this is pressed, you need to lit 8 LEDs. When this is pressed, you need to generate a square waveform in P1.2. Okay, this is a program. Try doing this program, execute it and check. Thank you.